So we were asked for this series, does it diverge, does it converge? So let's ask ourselves a few questions. If I do a divergence test on the whole thing, am I going to get anything? Well, it's going to be a little hard with that -1 operator there, right? When you see a -1 operator, you should immediately throw out the comparison test and the limit comparison test and all this other junk, unless you need to use it later on. But use the alternating series test. And basically what that says is, okay, get rid of the -1 operator, bring it out to the front, and just look at A sub n. Look at everything except for that thing that's flipping back and forth from positive and negative. Basically, look at the series of 1 over n to the third plus 4n plus 1. What this allows you to do is take both tests that you need to do for first the divergence test and then the always decreasing test. So for the divergence test, we simply take a limit as n approaches infinity for this term here. So we take 1 over n to the third plus 4n plus 1. That just turns out to 1 over infinity. And right, this is the limit of our partial sums minus, or our sequence of in our sum, minus this operator that's switching from -1 to +1, -1, +1, -1, +1, right? So this will just turn out to 1 over infinity, which is 0, because if I have one cookie and I split it in infinite ways, you're going to have none of that cookie left. You will not even have atoms of that cookie left. That cookie will be quarks and nothing more, because you can't destroy matter. Kind of a weird comparison. But anyways, we are indeterminate by the divergence test. We do not know if it diverges or converges. So what we have to do next, because we can't, if we got any value other than 0, we'd say divergent. We'd check a box and we're done. But here that's not the case. So we have to keep going. We need to do what's called the always decreasing test, is what I call it. Basically express as a function 1 over n to the third plus 4n plus 1. Now take the derivative of it, f prime of n equals, and you need to take the derivative. So this is just a simple quotient rule. I'm going to go ahead and do it here. I'll explain how I'm doing it. U is 1, u prime is 0, v is n to the third plus 4n plus 1, v prime is 3n squared plus 4. Okay, so f prime of n is equal to v times 0, so that's going to be nothing, minus u1 times v prime, which is this, all over v squared, which is n to the third plus 4n plus 1. Now, my point here is that everything we plug in here is going to be negative, right? Because that negative sign that we could pull out in the front is going to dictate positive or negative, because we're always plugging in positive values. We're not subtracting anything, and they're square terms, cube terms, and constants, right? So that negative was going to say, okay, all of your terms are going to be negative. Now, a derivative is a slope of a tangent line. So if the slope is negative, that means the function is always decreasing, right? A little change in x over a little change in y is always going to yield a negative result. So because the derivative is always negative, thus always decreasing our series, we know that this series is going to be convergent. And if you need a little bit of a visual proof, let me explain. Alrighty, so do your simple divergence test. Okay, find what that is. What this says here, why we look for this, is imagine that we have some starting value and we go to our first sum. We plug in n of 0 and we get some sum. It's going to be positive, right? Or sorry, we get a -1. So imagine this is going in the negative direction, this is going in the positive direction. Our next term we're going to add. But what happens is, because we're always decreasing, this value that we get is going to be less than whatever value we have. So we're only going to go back so much, right? And then off of that value, we're going to subtract a little bit from it. So it's not going to bring us quite as far over again. It's going to bring us a little bit over, but not quite as far. So this will keep happening and happening and happening until we reach some finite value, where it's just going to ping pong back and forth. Imagine two ping pong players playing table tennis. They're hitting, and every time they take a step closer. That's kind of the sum, right? It's getting closer and closer and closer as you go towards infinity. So, and they're going really, 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 really close to each other, right? So it will converge because of that. If we found that this was always increasing, well, imagine instead of playing ping pong and you're taking a step forward every time you hit the ball, you're taking a step back and a step back and a step back. You're basically growing from each other, right? So that would diverge. But here it doesn't turn out to be that way. And if we found at the divergence test it to be non-zero, well, they would diverge from each other. So quite simple. Hopefully my explanation made sense to you. Hopefully our discussion here made sense. If you did enjoy, please like, comment, and subscribe. I hope that you have a wonderful day.